So let's go over this homework problem. So we have a contour map for this function f on this square that is from 0 to a on the x-axis and from 0 to a on the y-axis. So we're going to use the midpoint rule with m and n equal to 2 to estimate this double integral of this function over this rectangular region. Okay, first of all, because we have m and n equal to 2, so for this rectangle along this x direction, we're going to divide that into two sections. So m is equal to 2, so we have two sections, right? This is one, and then there's another one, two sections. And then also on the y direction, we divide into two sections also. So m and n is equal to 2. Okay. So because this is 2 by 2, so we're going to divide this rectangular region here into 4 rectangles. Each one have equal area. So the area for this small sub-rectangle over here will be equal. Okay, so we have 1, 2, 3, 4 sub-rectangles. Now, and then we're going to take the midpoint. So this 1, 2, 3, 4, those are the midpoint right there. Okay, so we indicate that. So, but first, let's find the area for each sub-rectangle. So this small rectangle, what will be the area? Okay, so let's call the area here delta A. Okay. That is the area of one, say, sub-rectangle. Okay, so we know that that will be the total, the area for this big rectangle divided by 4. So the big rectangle is 8 times 8, so that's 64. So it's 8 times 8, and then we divide it into 4. So that will be 16. So each sub-rectangle will have area equal to 16. Now, the midpoint rule says that we are going to estimate this double integral over here. We can say this is approximately equal to, so you're going to use the area of each subrectangle and then multiply with the function value at each middle point. So that's what we're trying to do. Okay. So let's take a look at this middle point here. What will be the function value? Well, it looks like it is between this level curve 40 and 30. So what is the function value right there? Let's think about it. This is about, well, this is 30, this is 40. This is more toward 40. So maybe let's say it's 37, okay? So how about we say it's 37? So it's 37. I wonder if they will accept that if that is maybe plus or minus 2, I guess they still accept it, I think. Okay, and now let's look at this middle point here. Looks like it's between 10 and also what else here? This is 0, and this is also 0. So 10 and 0 looks like it's more toward the 0. So if you go like this, so maybe estimate, let's say he would be 4, right? So 0 and then 4 and then all the way to 10. So maybe let's just say it's 4. Okay, I guess they would have some tolerance if you're plus or minus 3 or something. Okay, and then you also get the function value over here, which is this is between 20 and 30, but it's more toward 20. So let's say 24. And then finally, adding the function value at this middle point, the midpoint, this is between 20 and 30. It's more towards 30. Let's say it's 27. So, and then if you do the calculation, that is equal to 1472. And then we would say, then we would say this double integral over this double integral is approximately 1472. Okay, so that's part A. So part B, we're going to estimate the average value of the function. So since we already estimate this double integral, okay, so the average value of the function, we have a formula. It is that double integral that we have here. It's going to divide by the total area, this total area. So because this is the integral of the function over this big rectangle, and if we use that to divide the area of this rectangle, we'll get the average value of the function. And the area here we already calculated it is 8 times 8, so it's 64. So the big rectangle is 64. So that is about 1472 divided by 64. That's equal to 23.0. So, and that the answer here is 23.0.